am I live right now? I mean, yes or no? Just please give me a small way on the chat. So I am currently looking into your chat right now. Am I live? So yes or no, guys? Just please tell me that. Then accordingly, I can take things ahead. So hi guys, how are you all? So yeah, so I can see now people coming up in the live. So how are you all? So how's you all guys? And what are you all doing right now? So first and foremost thing, I hope that every one of you are good in terms of your places. So which all cities you guys are joining? कौन से city से join हो रहे हो? I mean, like, just put this one thing into the chat right now so that I will be able to see you all guys in the chat accordingly. Okay, so which all cities you all guys are joining from? So just please let me know in the chat, and let me just be familiar with this batch. Then I will be going ahead. What we say, then introducing to your sir who will be taking this whole class ahead with you all guys. So yep, so now I can see people mentioning from Dhanbad, Bhubaneswar, Faridabad, Hyderabad, Srinagar. Okay, Srinagar, Jharkhand. Okay, amazing. I mean, like Jammu and Kashmir. Jammu and Kashmir people are also there. Then afterwards we are having Raipur. Okay, Nagpur, Nellore, Vizag, Bihar, Patna. Okay, so I'm having people from like different cities of the country. Okay, so good to see every one of you. So this is Sai Kiran from Let's Upgrade, and I am the chief upgrader and founder at Let's Upgrade. So I have founded Let's Upgrade in the year of 2020, and here we are with 230,000 students, and still counting with each and every upcoming batch going forward. Okay, so thanks a lot for joining in along with us, and I will be just introducing you to like what is Let's Upgrade, why you guys should be learning data structures and algorithm from us. Okay, how you guys will be learning data structures and algorithm by Let's Upgrade, and what will be the time, what will be the platform, how is the whole teaching scheduled, what would be the time for the learning experience, who will be your instructor. So these all questions are there which need to be answered, which I will be answering to every one of you right now in this next 10-15 minutes. In the meantime, your trainer is joining. So okay, so now I am Sai Kiran, and please, every one of you, I will be introducing just next 5 minutes, okay, 5 to 10 minutes, we will be taking to understand what is Let's Upgrade, why you should be doing data structures and algorithm right now along with us. Is it clear? Every one of you, is it totally clear? Yes or no? Please give me some thumbs up or some kind of heart emoji or something into the chat so that I can take it ahead. Okay, so hi Divya Agrawal from Aligarh. Okay, then afterwards I have Shivanand Yadav and Anuraga. Okay, so fine. So thanks a lot for every one of you to joining this particular thing. So please give me a go ahead in the chat so that I can actually take things ahead accordingly. And I'm waiting for your chat right now. Okay, so I can see people messaging a few things here. Thanks a lot. Hi. Okay. So first of all, let me just start with what is Let's Upgrade? Let's Upgrade is a community which believes in learn, build, share, grow. Until unless you don't build projects, until unless you don't experiment and experience few things, you will not learn some or other concepts completely. That's why we have created Let's Upgrade, where no theoretical learning happens. It's actually let's implement the stuff and let's start learning it. That's what we all believe and belong to. And for that experiential and experience-based learning, I welcome every one of you to Let's Upgrade. Okay, so now let's go ahead in terms of what is the teaching pedagogy at Let's Upgrade. So then once you understand the whole teaching pedagogy, then you will be understanding what you will be learning in this whole program and how you can take it ahead accordingly. Okay. Why are we here? We are here to learn data structures and algorithm. So data structures and algorithm पढ़ने के लिए हम यहाँ पे हैं. It's what we say 9 to 10 hours of online learning what we guys are providing. If at all अगर आप assignments और projects अगर गिनते हो So if at all you count projects and assignment, it will be totally 20 plus hours of learning what you will be provided here along with us. Okay, so that's what it is to learn data structures. Start with it. That's why we are here. So what all you can expect from this program? This program is consisting of like what we say 10 plus hours of live interactivity based learning, where you will be having instructor like me, and Subrat sir will be joining up here. So that's what he's the person who will be taking it ahead. And Let's Upgrade server is not working. Okay, I don't know what is the problem, maybe, but yes, I hope that you all guys are able to see me on YouTube right now. Okay, so fine. So now whichever like whatever class you may be in, whatever you guys may be doing, data structures and algorithm is very much important for every one of us, and that's where we all will be learning what we say data structures and algorithm along with some practical knowledge here. So that's what. Then how to attend this class? Starting 2 classes will be happening on YouTube. Okay, YouTube as a platform will be where our classes will happen. The first initial 2 classes. From the third class onwards, we will be moving on to what we say learning management portal, where you all guys will be like having letsupgrade.in/my programs is where we all will be going. Second 2 days यहाँ पे class होगा, आज और कल. Wednesday say your classes will be happening from on Wednesday. Your classes will be happening on the learning management system, which is on letsupgrade.in/my programs. You all will be getting reminders and everything in your mail. So please subscribe to Let's Upgrade YouTube channel first, and at the same time the emails what we guys are sending. Okay, so any goodies for attending daily? क्या कुछ हमें गिफ्ट मिलेगा क्या? पढ़ना तो है हमें, like I mean we all want to study, but apart from study, are we going to give any kind of goodies or swags to the people who are attending daily? Yes, we have something to motivate every one of you. That is, we give away Google Home Mini or Amazon Echo to the top 2 people, to random 2 people. Okay, you just have to fill in your attendance daily. That's it. What is it you have to do? You have to just fill in your attendance daily in the attendance form. That's it. You just have to fill attendance daily in your attendance form, and we pick a random 2 people at the end of the whole program and give either Google Mini, that is home, or either Amazon Alexa. We already gave away more than 10 Amazon Alexas till now. So we are on track to give away at least 2 Amazon Echo or Google Home Mini in this batch also. So please be with us, and let's start learning accordingly. Okay, so what do you guys think about it? Echo and Google Home Mini. Just please tell me that one thing. I mean, are you guys excited about it? Okay, so are you guys excited about like Google Home Mini and what we say Amazon Alexa? So we may be like stopping giving Amazon Alexa very soon. It will be all Google Home Mini for the goodies. Okay, top 2 people, random 2 people, and at the same time we will be also giving some kind of coins to motivate you all guys for attending your classes regularly. Okay, so okay, fine, amazing, clear. So now let's go ahead. Where will be the exam held? Abhi, you need to have a certificate. Okay, so you all will be receiving certificates for attending this program. But where you will be giving the exam? You will be giving the exam in a dedicated portal, an online portal, where you all guys will be like what we say just going and giving some MCQ exams, MCQ related exam, at the same time some subjective related exams you will give. We will check that thing, and then we will be showing you the results accordingly. Okay, so who will get certificates from where? We will be providing certificates from Let's Upgrade ITM group of institutions. We will be providing certificates from these, and all the people who will be completing the exam and providing attendance on day-to-day basis, they will be eligible for the exam, and the people who clarify the exam, they will be provided certificates. Okay, so now all the best. Every one of you are rowdies in your own careers, and I just want to tell this one single part, that every one of you are behind one thing, that is making best in your career. This is an opportunity what we guys are providing. to every one of you to make sure that you all have a equal start and in a fun manner start learning and loving data structures and algorithm. And the one of the biggest reason why you should be learning data structures and algorithms, simple: every placement you will be sitting for, interview you will be sitting for, you will be asked data structures and algorithm. And for that one thing, you all should be perfecting your data structures and algorithm. And here is what the platform which we want to provide and disrupt this whole market in terms of who are providing this all high quality and like even not this much high quality product for very higher price. Okay, we want to disrupt it. That's what is Let's Upgrade, a community to share and do things. So I just hope that every one of you will be a part of this thing and take it ahead. Okay, one last thing which I want to tell, and then I will be taking things ahead accordingly, and I will be introducing you to. So Subrat sir is going to be your trainer. Okay, so Subrat sir, hi sir, how are you? I think you are mute. Actually, I think you are mute, Subrat
Hi,
sir.
hi.
Okay,
Yeah,
okay.
I
So Subrat,
have unmuted.
yes.
Hi, good evening.
Yes, Subrat sir is going to be your what we say a trainer who will be teaching data structures and algorithm. He's a very well-known and renowned trainer in terms of if at all any SRM students here, I don't know, or if at all any other big like VIT or any kind of like very big institutes students here, just go and visit Subrat sir's profile once, and you will understand from where this person belonged to. Okay, so this person had taught and trained more than like bulks of tons of students for placement preparation, and this is the same trainer who is going to train you all for data structures and algorithm. Okay, I hope that you all guys will be like taking it accordingly and ahead. So one last thing which I want to tell, and then I will be handing over the platform to Subrat sir, and I will go to background. So that is about your community. So every one of you may be having Let's Upgrade communities access, right? So community.letsupgrade.in. So let me share in the screen just 1 minute. Okay, so here is your community. Yeah, so in this community you may be having your own badge. Okay, so you all will be having your own badges. For example, if I go to the group, inside the groups you will be able to see your own batch that will be data structures and algorithm. Okay, so I just need to find out which batch is yours. Okay, so now see this one, data structures and the same link for this might have already been sent out to you in your emails. Just go here, introduce yourself, and we will be crediting 40 Let's Upgrade coins, which you can use for buying any Let's Upgrade advanced premium or like professional or what we say master course for free of cost. Okay, go introduce yourself here. That is let's upgrade dot in. It's community dot let's upgrade dot in. Inside groups, just find out this group which will be there. Join this group, and you will be like introducing yourself here. All the people who will be introducing themselves here will be awarded 40 Let's Upgrade coins. Just introduce yourself from where you are, what are you doing, and that's what. Okay, so now I'm done with the all introduction part, and I'm handing over the whole thing to Subrat sir. Yep. So I hope that every one of you are clear. Just give me a emoji or something hi-fi in the chat so that I can hand over this whole thing to Subrat sir. Yep. Okay. Just tell me something in the chat, guys. Okay, our site is probably crashing down right now because of the sheer amount of load which we are getting. We will solve it. Maybe we will solve it. Very sorry for that. But the stuff is right now. You all will be starting learning with Subrat sir. Just give us a high five in the chat, and then we can go ahead. Okay. So thanks a lot, guys. Bye bye. Take care. Have a nice day. And over to you, Subrat sir. Don't forget to give your attendance, guys. It was there in the description. Okay, so the attendance form will be there in the description. Just go fill it out when the end of the class. Yep, over to you, Subrat sir.
Hi, good evening, guys. Good evening, everyone. So all set for today's session, right? So this is our first session about data structure and algorithm. I hope everyone here is very much excited for this thing. So we would start with a very basic thing actually today. So okay, before I get into this, just guys, just like be cheered up. So just say yes in the comment box. I just want to say, I just want to see many yes there in the comment box. Yeah, good evening, everyone. Yes, good evening, Dinesh. Good evening. Everybody is excited, right, for this session. So let's start then. Yeah, I see so many yeses there. So great then. So let's start with this. So I would start with this simple example, guys. Maybe a question. Okay, the very first question to you before starting the session. So you have let's say you have three options. Okay, you have plain rice and you have fried rice and you have let's say biryani, and you have to go somewhere. Maybe you have an interview, for example, and you have to eat one of the this as option: fried rice, plain rice, and this stream rice or plain rice and biryani. Okay, so which one would you go for? You have, let's say you have the interview after 2 hours, you have to eat it and you have to go for the interview. You have these three options, so which one you would go for? So I would like to have the answers in the comment box. Yeah, guys. Biryani. Okay, Sairam says biryani. Okay. Plain rice. Okay, I see plain rice, one plain rice, but most of the answers are biryani. Okay, yeah, biryani is nice, right? So, okay, let me add one condition here. Um, now, so you had option, right? Plain rice was kept, and biryani was kept, and fried rice was kept, and you opted for this biryani, right? Okay, because that's very delicious. Let's say now I'm adding one condition, that is you have to prepare it and then you have to eat and then go for your interview. Then which one would you go for? Answers, please. Okay, got the question, right? So now you have to prepare it. You have to prepare it by your own and then have it and then go for your interview. Then which one would you go for? Fried rice, biryani, or this plain rice? Plain rice, right? Because yes, it would save time. It would be prepared in very less time. You don't have to struggle more. And yes, you have an interview after 2 hours, so obviously you would need to complete this thing in less time as much as possible, right? So, so what we concluded here, we concluded here that okay, when this time thing is there, like we have to select the something best among here. We had three options and we selected best depending on the time. So when there is time constraint, we go for that which would be completed in less time. That's exactly we do when we have certain ways to solve a problem. Okay, with this I would like to get into this topic of algorithm, guys. So what exactly is algorithm? So take any work or take any task, may it be, let's say, making tea or something. Making tea would also have different ways to do, right? So if I give the task of preparing tea to four-person, this four-person would make or will prepare the tea in different ways. Okay, and among those ways we'll choose the best one. Okay, so these ways, what are these ways? These ways are nothing but they are called algorithm. So algorithm are you can say they are certain number of steps, some finite steps which are there to solve a problem, right? Okay, so we have different algorithm to solve a task. Given a task, we can have like four ways to do that task. But among those four ways, we have to select the best way. Okay, likewise we have to select the best algorithm among those four algorithms. So how can we say which one is best? I just mentioned one thing there, time thing, but actually in your algorithm thing there are two things. Okay, one is your time complexity, one is your space complexity. Time and space, these two are major things upon which we decide which algorithm we should pick up actually, guys. Okay, so uh, yes, one more thing I just want to add here. You have to compromise between this time and space. Okay, when you want very less space, you might have to compromise with time, and when you have to complete this in very less time, you may have to compromise with the space thing. So you have to compromise between these two things, guys. So keep this in mind. So I hope this thing is pretty clear. Like, what is algorithm? Basically, certain number of steps to solve a problem. Okay, so basically in a program, whatever we write, we are implementing those algorithms in a programming language. Basically, that's all, right? Okay, so that's what we understood up to this point. This is your algorithm, and we have to so given a task, there can be any number of like n number of algorithms to solve that problem, but we go for the best one, and best one is decided upon time and space complexity. Okay, one more thing. Nowadays, space is very cheap actually. It is readily available. You get this 2 TB hard disk with maybe 5,000. Yeah, it's very cheap. But time is very precious. The time is very costly, right? We don't have much time. Everyone wants that the task should be completed with very less time so that I can hang out with our friends or maybe watch a series on the Netflix and kind of that. So everyone is running short of time and every time. So yes, so major concern here would be on time complexity actually, guys. Space, as I mentioned, it is nowadays it's very available very cheaply. So we majorly focus on the time complexity thing. Okay, so with this, I would actually like to like ask a question, basically an MCQ here, so that I would love to see your answers. Answers you have to submit it. You might have received. Okay, you have to go to this Kahoot link and you have to respond with your answers. So can I have the question? Just a moment, guys. It would be shared with you. Just a moment.
Just a minute, so I'll be sharing it.
Okay, so guys, so this is a link, guys. You can visit this link. Yeah, Katie, can you please there's some background. Yeah, guys. So quickly get onto this link and answer the question. Can I have like can we have the full screen of this one, Katie? Can we have this full screen mode? Okay. Also, yeah, fine. We can have this link on the chat. Yes. Yeah. Just a moment, guys. So it would be shared with you. Okay, so it's just a bitly link, right? So you can just go with this. So just this is bitly DSA 11. Okay, so you can go with this. Okay, 131. Sorry. So no, it's quiz 3. I just wait a second, guys. Wait a second. Yeah, Katie. So I think you have shown this quiz 3 link. So can we get back to this quiz 1 link?
Yes, sir. Yes, sir. There was a bit confusion. So,
Okay. Yeah, sure. So just hold on a second, guys. Just don't go to this link because this is quiz 3 actually. And also you can put in the chat actually the link. The link is not opening. Okay, so yeah, I think that's some internal issue, guys. So maybe we would look onto that. So we would let's continue with the thing. We'll get back to this question. Okay, so don't worry about it. Sorry for this. There might be some internal issue with that. So Katie, we would get back to our like theory discussion, and we'll get back to this. Meanwhile, you can just look for what is the
yes, so
problem.
sorry, guys. There's
And you
some
can, yeah.
confusion. All
Yeah,
right,
no
sir.
issue. We will continue with the discussion. Meanwhile, you can look over that, right?
Okay, sir.
So next time we can, yes, we can share in the chat. Okay, fine. So yeah, guys. So yes, we were discussing about this algorithm and selecting the best algorithm based on this time complexity. And I said the major concern would be on time complexity. Two things are there, excuse me, time complexity and space complexity, but we would be looking forward for this time complexity more. So let me share a screen with you, just a moment, and it would be good to discuss something. Yeah, so I hope the screen is visible to you all. I have shared a whiteboard basically with you. Yeah, it's visible, right? Okay, you can also give me some confirmation, guys, in the chat box whether it is visible. So we would be using the C and C++, majorly C, guys. Okay, would be basically using C. I'm not saying will use C++. Majorly it would be C. Sometimes when I don't like I like to write much bigger syntax, then I would go for C++. But logically it would be the same thing. Okay, you don't have to worry about that. So yeah, okay. So what is this time complexity? What is this time complexity, guys? I mentioned this time complexity, but what is that basically? So this time complexity, which we denote as T of n, for any algorithm, T of n will denote its time complexity. It would basically show the behavior of your algorithm, like how it grows. Okay, how it grows with uh, um, increase in the input size, you can say, or how much time it takes with increase in the input size. When I say increase in input size, what does it mean basically? So what is this input size? See, in some problem your input size may be number of values you are giving or number of inputs you are giving. In some question it may be the um, it may be one value, but how much large it is. Like if you are working on array, you may be you may think that okay, the total number of elements the array would be storing, that is the input size. But let's say we are talking about finding factorial of a number, then you would be concerned on okay, how large is that number, right? So that is how we go for this time complexity, guys. That is how we try to understand this time complexity. So basically it is the behavior of your algorithm, or how does it grows, or how much time it takes with increase in the input size. This is your time complexity, and there are various notations actually through which we denote this time complexity. Okay, and there are this big O. We have this. Okay, can anyone answer me before I write down everything? Can anyone answer me here? Like how many notations are there? These notations through which we denote or identify this time complexity are known as asymptotic notation. You might have heard this term. So can you say me basically how many asymptotic notations are there? Okay, Pranay says three. Okay, I want more answers, guys. How many asymptotic notations are there through which we basically denote this time complexity? One I have already mentioned, big O. So okay, I am getting this all three, like many three. Someone said five. Okay, many three. Okay, to be very clear, guys, actually there are more than three asymptotic notations. Okay, we have actually five, but among those we use only these three. What are those three we use? That is big O, big omega, and this theta. Okay, this theta we use. What are other two? Other two are nothing but little o or small o. Small o you can say, little omega or small omega you can say. Those are actually reserved for research purpose. We don't use that much. We are only concerned about this. We use these three things for our purpose. And among these three, we actually are more concerned about this big O. Why big O? Why not big omega? Because this big O denotes worst case time complexity, guys. Worst case. I hope it is clearly visible to you. So big O denotes worst case time complexity. Big omega denotes best case time complexity. This is best case. Okay, and this theta, it shows or denotes average case time complexity. So we are worried about what would be the time or how much time this algorithm gonna take in worst case scenario. Okay, so we must be prepared for worst case, right? So this is your time complexity, guys. We go for big O. If we are saying okay, the time complexity of an algorithm is this, then we are basically saying the worst case time complexity of an algorithm is this. Okay, right? I hope this is clear to everyone. Average case, we go for worst case. When let's say we are comparing two algorithm, there are two algorithm A1 and A2, and you want to compare these two algorithm. So you would be comparing them on basis of worst case time complexity. At worst case scenario, what time complexity or what time they would be taking? What is the order of time? Yes, one more thing. Um, when I say the like how much time this algorithm is taking when we increase the input size, I'm not asking about the exact time, like how many minutes, how many seconds. No, basically this would be an order of the input size actually. Okay, like whether it depends on n, like how it depends on n where n is nothing but the input size, or whether it is n square, it depends on n square, or maybe it may be log n, it may be root n. So how it depends on this input size, that is what your time complexity, guys. Okay, don't think that okay the exact time, this hour, this minute, this second. No, this is not exact time, but this is basically an order of time. Okay, how it depends, the relation with this input size actually basically would be the time complexity. Okay, yeah. So when you are comparing two algorithm, we would compare always on the basis of worst case scenario, guys. Okay, and yes, one more thing also. So when you are comparing this two algorithm, don't ever assume that okay, it has a very less number of input. For 5 input, let's compare this two algorithm on the basis of time complexity. You shouldn't do that actually, because when you have very less input, when input size is very less, algorithm may behave differently, and when you have some certain number of input, it may behave differently. Yeah, that there is a certain point. Okay, there is a certain point after which it would behave similarly onward. After that point onward, it may behave differently, like okay similar, but before that it would have a different behavior. Let's say okay, for depicting this one, I would okay I would draw a small graph for you. So this is, let's say, x-axis is n, the input size, okay, and y-axis is, let's say, time complexity. So here is a graph. So this is my fn, which is, let's say, you can say, okay, actual time, you can say, of the algorithm f of n, okay, and then there is this, let's say, then there is this. So what is basically this one? So I would call this as C of Gn. This is another function. So we are depicting a graph between this time complexity and input size. Time complexity versus input size. I'm taking a graph here which denotes the time and input size relationship basically. Okay, so you can see here after this point, it behaves differently. These two graphs, like it behaves like you can say differently than this part. Okay, if you see this part over here, it behaves differently compared to this part of the graph. Okay, but after this point onward, it behaves like always the C of Gn is greater than f of n, right? Okay, the C of Gn is greater than f of n after this point always, but that is not the case before this point. So you should not actually assume, when you're comparing to algorithm, you should not assume that okay, we have very less number of input. You should not assume on the basis of very less number of input. You should be assuming, or you should be comparing to algorithm assuming that okay, it has a very large set of input. Based on that you compare actually. Okay, right. This graph is something else, guys. I was just trying to make this point clear, like what happens when we assume there is less input. This graph is a different thing which we cannot get into so much detail in this very less time, so I would like to have this thing later for the advanced course. Okay, you would see this graph again there, so I'll be removing this for the time being. I hope you understood my point actually. So we should not compare to algorithm assuming that it has very less input size. That's all. Okay, so Katie, so can we have now that MCQ? Like, is the issue
Yes, sir, it's resolved, but actually, we'll give the second quiz right now. The quiz one will be given at the end. Is it fine?
yeah, fine, fine. Sure.
Yes, sir. So I'll be sharing my screen. Just a minute.
Yeah, sure. Just a moment, guys. So the link is being shared, and you can just directly go to the Kahoot platform, and there you can respond with your answers. Yeah, I hope it's visible to you all. Can we have a full screen mode, Katie?
Yes, sir. Yes, sir.
Yeah, okay. So yeah, guys, so it's just bit.ly link bit.ly/dsa_211. Yeah, for your simplicity, I would also put this thing in the chat so that you can directly click there.
Yes, sir. Okay, I'll be also sending it.
So guys, yeah, so you can click on this link, guys. So it's basically DSA131 bit.ly/DSA131. So just take a moment out and fill your response and just mention here if you are done with that, so that we would continue with our discussion.
अरे यार.
Kitty can be on mute and do the following. Yeah, I have put already in the chat. So
Sir, it will be quiz 2. I'm so sorry. It will be
yeah, no issue.
211.
Okay, guys.
Yeah.
So it would be 211, guys. 211 DSA underscore 211. Yeah. Kindly excuse us, guys. So that was a small mistake. Okay. So go to this DSA 211 bit.ly/ DSA underscore 211. And pin is also mentioned, so you can just enter the pin and go there. Yeah, guys. So the link has been shared continuously in the chat. So I think you would not have any problems. Just go to that link and yeah, let me know here with just a done when you are done with the submission of your answer. Meanwhile, okay, you just submit your answer. We have some examples here to discuss after that. So once you are done, we can actually continue with our discussion. Yeah, Shwara, pin is being shared. You can see here it's mentioned in the video itself. So yeah, I see many done here. So I hope every one of you have submit your response in the Kahoot. So let's. I think we should continue with our discussion now. Okay. So first of all, there are different types of time complexity. So there are some. I would not say various types of time complexity. I should say actually various time complexities. Okay. So let me again share a screen with you guys, and we would continue discussion from the same point. Yeah. Let me clear this out. This thing. Okay. So we have some time complexities. One of them is linear time complexity. Okay, one is linear and one is constant time complexity. So what do you mean by this linear time complexity and this constant time complexity? So I think every one of you have done this searching of an element in an array, like linear search basically. I don't want to get into that linear search right now, but every time when you are comparing with all the element of the array, or you are going through all the n values, then this would be called as linear time complexity, as it depends on the whole n thing. Okay, all the n elements you have to check, right? So it is linear, big O of n. Okay, and this constant, when I say constant, what is it? So it would take some constant amount of time. Let's say you have some statements here, like printf hello. Okay, then we have printf hi. So we have some statement, let's say two or three more statement. So this statement takes some constant time, this statement takes some constant time, and also all this statement, let's say they are taking constant time. So in total they take constant time. You might say that okay, this would take 1 unit of time, this will take 1 unit of time, this will take one and one. So total you may say okay, this is making yeah 5. So you would say okay, this is big O of 5. Yeah, I'm not saying you were wrong, but we normally we denote constant thing as big O of 1. Okay, or sometimes we say any constant big O of C, any constant. But popularly we use this big O of one thing to denote this constant time complexity. So in time complexity thing, what we should understand one thing is we are ignoring this constant values. Okay, like if your time complexity comes out to be kind of this 7n square plus 3n plus 5, for example, let's say, like it depends on n, it depends like on one constant time. Let's say some time complexity is dependent on n in this way as depicted by this equation. So here, what we have to do is we have to ignore this constant term 7, 3, and 5, and also we are concerned about the term which has the highest degree. So we would say, okay, this is basically big of n square. We don't have to write like all the things here. We can say it is big of n square. So first thing is we are ignoring the constant terms, and also we are focusing or we are taking the term which has the highest degree. Okay, right. So this is linear. This is constant. Then yeah, let me clear this out. I hope this point is clear to everyone. Okay. Yeah, attendance link would be shared. Just like let me finish the few things and we can go to the attendance thing. Okay. So then yeah, so linear and constant we have done. Then we go for this quadratic time complexity. So what is this quadratic time complexity? Basically, if you say big of n square, we say it is quadratic time complexity. Okay, so this is like it depends on square of n. Whatever input size, it depends on square of it. Okay, so basically order of n square. So t of n is order of n square. That is basically quadratic. And yeah, logarithmic log of n, obviously log of n. I would give some example basically like all of this. Let me start with this constant. I think I don't have to give any example because I have discussed what is constant basically. Let me give you an example of linear. So let's say I have a loop for I equal to, I'm basically talking about iteration statement, guys, time complexity of iterative codes. Okay, so for I equal to 1, I less than equal to n, I plus plus, let's say printf, and I will print here let's upgrade. Yeah, my handwriting is not very good, guys, I know that, so kindly manage a bit. I would work upon this. And there is one more loop. Let's say I have for I equal to 1, I less than equal to 100, and I plus plus, and printf the same thing, let's upgrade. Okay, so these are the two things, these are the two code snippets have been given to us, or two loops that have been given to us. Okay, so this loop, if you talk about this one, this loop, how many times this loop is running? 100 times. Like it, I starts from 1, I less than equal to 100, and every time we are incrementing I. So this loop is going to be executed 100 times. So basically, you can say this let's upgrade is going to be printed 100 times. So you would say, okay, time is 100 or order of 100. Okay, we will not write big of 100. We can write big of 1. Any constant, you can just write it big of 1. Okay, constant time complexity. Here, we're not sure, right? What is the value of n? So whatever value of n, that many times this loop is going to run. So basically, it depends on n. So it starts from 1 and it will go till n. Every time incremented by 1 and 1. So 1, 2, 3, 4. So it is running n times. So time complexity would be, sorry, big of n. Okay. Similarly, let me give you some more example. Then yeah, if I have this for I equal to 1, I less than equal to n, and I plus plus, then I have for j equal to 1, j less than equal to n, and j plus plus. And let's say printf, I'm just taking high. See, I'm just writing this printf in short as pf. Don't write pf in your actual code. Okay, I'm just writing in a short form here. So pf high here. Yeah, so you can see this loop would run for n times. This loop would run for n times. So in total, this thing would be printed n into n, that is n square times. You can say time complexity would be big of n square, right? You can say, yeah, big of n square. This is an example of quadratic time complexity. But what I need you to do is, guys, I don't want you to see this or find out the time complexity in this perspective. Okay, see what happens in when you go for this recruitment drive and all. They might give you a code and ask you to find the time complexity of this code snippet. So you really need to understand what is being happening, like what is going on there, and how to find out the time complexity. Yeah, this is pretty like simple code. So you can say, okay, this outer loop is running n times, inner loop is running n times. So total it would run for n square times. So time complexity would be n square. Fine, but I want to look on this code or the way actually in a different way. I want you to see this in a different way. What? Don't think about how many times this outer loop and inner loop is running. No, just think about how many times this thing would get executed. Obviously, the number of times this high would be printed is the total number of times the loop is getting executed, and that would be a time complexity, basically, right? So I want you to understand this. I want you to see in this perspective actually. Okay, so how? So just take I and J. Okay, so I would be, when I is 1, J would start from 1 and it would go till n. So how many times this high would be printed when I value is 1 in the first iteration? N times. High is printed n times. Similarly, when I is 2, J would start from same thing, n. Okay, right? Also n times. Similarly, so on, when I value is n, J again would run from 1 to n. So again it is n times. So how many n, guys? N plus n plus. So the total number of times this high is printed is nothing but you just add them up. N plus so on up to n. How many times n you have added? N times. So that makes n square. Yeah, same thing. You'd get the same answer n square here, but the perspective you have looked is different here. Why I have shared this? Because it would help you while solving some other question. We'll be getting back to that. Yeah, Katie, can we have a link now? Like, is that fine now? Is it working now?
Yes, sir. Second link is work.
The next question, can
I'll be
we?
sharing the third quiz link now.
Sure, sure.
Sure, sir. The link will be also given in the chat. I'll send. The moderators will send it. I'll be sharing the screen right now so that they can get
Yeah,
to the
thanks
link.
for that. Yeah, guys, so the link is shared also in the chat, and it is being displayed, so you can carry on with the question and submit your answer. Please let me know when you are done with it so that we can continue our discussion. So we are having a great discussion here, and yes, we are having even great quiz in between that, so it would help you people a lot actually. Just let me know, okay, when we are done with this. When you submit your answer, just let me know. Okay. Once you're done with this, we'll get back to some more question actually, some more types and some more examples based on this. Okay, no one has done. Please guys, let me know in the comment section if you are done with this. Have you submitted answer for the quiz 3? Done? Yeah, I see if you done here. Okay, I want some more done so that I would get confirmations that all of you have submit your answers, and I can go on to continue with my discussion here. Okay, I see some done here. So yeah, let's continue with our discussion. So Getty, how many questions did they attend? 2 questions. And the
Yes, sir.
first question we would they have done 2 questions, and the first question which they missed out would be done at the end, right?
Yes, sir. The first quiz link will be given in the end, along with the quiz 4 link mostly.
Okay, fine, fine. Just stop me whenever you have to share the attendance link with them. Okay,
Yes, sir. I'll be sending that. I'll be adding the attendance link in a while, like after 15
sure,
minutes
sure,
mostly.
sure,
Sure.
sure, sure. So yeah, guys, getting back to our discussion, let's have some more questions out here. Let me clear this out, and I will be discussing some more questions. So we have discussed 3 types of thing, like basically a constant, linear, and this quadratic. Okay, let's also discuss, excuse me, logarithmic. Let me give you an example of logarithmic. So let's say I have this code for I equal to 1, I less than equal to n, and I equal to I into 2, or let me just write in a short form. So I into equal to 2. Right, this is my equation. I equal to 1, I less than equal to n, and I into equal to 2. And it says, let's say the same hi. So the question is, what is the time complexity, or how many times this loop is running? Because yes, this loop would take some time. It would not be executed only once. Okay, that we need to find out. Let's say before this loop, we have certain statements. Let's say hello. Okay, then after it, let's say I have one more statement that is done, for example. So you know this would take big O of 1. This would take big O of 1, but this would take certain time, right? So you would say, okay, it is big of 1 plus whatever time complexity of this and big of 1. Okay, so what we do, we take the maximum between them. Even if you have a statement, let's say we have here one statement, statement which takes big of, let's say n, for example, and this statement, let's say it will take big of n square. So you might think that okay, it is nothing but n square plus 1 plus 1 plus n. Yeah, constant, we can just take it out and we can write n square plus n. Remember what I said. We would just take the highest degree term, okay, the term with highest degree. So we would say is nothing but big of n square actually. Okay, so whichever part would take a maximum time, we'll just take that one, because we are not really concerned about the exact time. We are just concerned about the order of the time. So this is big of we need to, yeah, sorry, let me erase all this stuff, excuse me guys, because we need to find the time complexity of the code snippet which I have given. Yeah, you have your question with you. You can give me the answer in the chat. So for I equal to 1, I less than equal to n, I equal to I into 2. So basically we are incrementing this I by 2 times every time. So let me tell you this. So let's say n value, let's assume that n value is 64. Okay, and I we are starting with 1. Okay, then next time I value would be 2 because we are multiplying 2. Next time I value would be 4, 2 times. Then next time I value would be 8. Next time I value would be 16. Next time I value would be 32, and next time it would be 64. Okay, 64 less than equal to 64. Yes, true. Next time it would be 128 where the condition would be false and you will come out of the loop, right? So we need to just see how many times this loop executed. So, or you can say in how many steps this I reached from 1 to 64. If you look here carefully, in 6 steps I reached from 1 to 64. So you just need to, 6 is nothing but the number of steps. The number of step is nothing but the time complexity. Okay, you can say k steps. K steps, that is the time complexity. You need to find the value of k. So what is the relation between, so in 6 steps we reach 64. 64 is nothing but n. Okay, so this is your n. So what is the relation between 6 and 64? That is what you need to find. How 6 is like, how k is dependent on n. If you look here, 6 is nothing but log of 64. When I say log of 64, it is base 2. Okay, in computer science, the by default base is 2. Unlike in mathematics, which is 10, here it would be 2. So log 64 base 2 is 6 actually, because we know 2 to the power 6 is 64. So you can say this time complexity k, okay, I'll just denote this as time complexity now, is nothing but big O of log n. Okay, yeah, I don't want this extra brackets there, parenthesis there, so I'll just say big O of log n. So if I is getting incremented 2 times every time, then we say it is log n. Similarly, if I would start from n and every time it gets divided by 2 to reach 1, even then we would say it is log n, because yeah, same thing, you can say, think of it. So now let's say I value 64, next time it would be 32, next time it would be 16, next time it would be 8, 4, then 2, then 1. Yes, end of the loop. Okay, condition would be greater than equal to 1. I equal to n, I greater than equal to 1, I equal to I divide by 2, if that's the question. So it would be log n, guys. So this is an example of logarithmic time complexity. Yeah, I would just write big O of log n. So this is logarithmic. Okay, I hope it's clear. Let me clear this thing. Yeah, see, when we write 2n, we don't have to write 2n, it's only n. Okay, 2 is a constant. If you're writing for base 2, okay, that is fine. Even if you don't write base 2, it is understood that it is base 2 in computer science. Okay, so let's go to some examples. Okay, guys, so I have picked up some example for you here. Okay, for I equal to 1, I less than equal to n, I star equal to 3, printf, let's say hello. So what would be the time complexity, guys, for this one? Yeah, put your answers. Yeah, Karthik, we would like, we'll see in upcoming classes. We'll take some example, we'll take some algorithm, and we'll try to improve it. Okay, so the very first step to do that, like to reduce the time complexity, to think about it, you first need to understand what is time complexity, right? That's what we are doing now. And yes, you get some MCQ question given, like you get some code snippet and you need to find out the time complexity. So first thing first, so let's go gradually stepwise. Okay, like we are doing this essential, then we can have advanced. So we are going stepwise, we believe in that. Okay, so log n, many of you are saying log n, right? Yeah, okay, yeah, log n base 3. Yes, you can say it is log n base 3 is a time complexity. Again, I can say log n, guys. Okay, I can say log n, no issue on it. Fine then. Yeah, if you want to be more specific, you can say log n base 3. No issue on that part. Yeah, you're correct. It would be log n base 3. So let's get to some more question. Let's say, uh, okay. Let's say I have this a equal to 1, b equal to 1, and I'm writing while b less than equal to n, a plus plus, b equal to b plus a. Okay, and then I have let's say printf, let's upgrade. I have this code snippet. Can anyone say what would be the time complexity for this one? Just think about a bit. Just try it out, guys, and just answer me. What would be time complexity for this one? A equal to 1, b equal to 1. So while b less than equal to n, a plus plus, b equal to b plus a, and there is a printf statement. So this individual, these are taking constant time. Even this is constant time. Even this is constant time. But how many times this all this statement would be executed? That's what will decide, right? The final time complexity. So please answer this one quickly. Okay, everybody, like I see many answer as big O of n. Let's see actually whether it would be big O of n or any other thing. Okay, let's try it out. Let's check. So yeah, n value, I'm just taking something kind of 10. Okay, so if you see here inside the loop, a is getting incremented first. So initial value of a and b was 1. A would be incremented first, and then we are adding a to b. So b was 1, then we are adding 2 to it. Okay, okay, in the next iteration a would be again incremented. Okay, now a is 3, then we are adding a to b, and b is getting updated every time, right, as b equal to b plus a. So next time we are adding 3 to it. Already whatever value of b would be there, we are adding 3 to it. Okay, so next we would add 4, because now a value is 4. In the next iteration we would be adding 4. If you see here, we have reached n, because n value I have assumed to be 10 here. So we now understand that, okay, adding 4, adding in the fourth step, when we added 4, we reached 10. Got it? So we can say, okay, this loop we need to just find, okay, how many steps? In 4 steps we reach 10. Similarly, we don't know the value of n right now, right? So we can assume, okay, at some step, at a given step k, or in kth step when we add k, let's assume that we are reaching n. Okay, let's assume at kth step when we add k, we reach that n. So this many times, so this k steps, this many times, this k times this loop is going to run. Like here 4 times this loop is running and we reach n. So likewise in kth step we are adding k and we are assuming that, okay, let's say we are reaching n. So this k value will give us the time complexity, the number of steps or number of times the loop was executed and these statements have been executed, right? So let's find out the value of k now, depending on this, based on this equation. So 1 plus 2 plus 3 up to k, it is nothing but addition of k natural numbers. So we already know addition of k natural numbers is nothing but k into k plus 1 by 2, n into n plus 1 by 2. Here I've taken k, so I can equate it with n. And yes, guys, So here k into k plus 1 by 2, you would say, okay, let's expand it and all. It would be k square plus k by 2. But once again, just remember what I said. We would be taking the term with highest degree, and we can very clearly see here highest degree term would nothing but it would be k square. So we are saying k square is equal to n. So what would be k? K is nothing but root n. So root n is our time complexity, guys. So for this code, time complexity is big O of root n, not n. So I hope this example is clear. We can, if it is clear, we can go to this the next quiz question actually. Okay. Along with that, we can also, I think, we can have also the attendance link, because I see many of you are asking about the attendance form since long. I think we can have also the attendance link along with the next quiz question. So this is root n, guys. Okay, please uh, understand it very well. It is root n. Okay, so basically what we did here, so every time a is getting incremented and being added to b. So 1 plus 2 plus 3 plus 4 plus likewise. So I'm assuming at kth step, when I add k, let's say we will reach n. Like here, when we added 4 at fourth step, we reached 10. Here at kth step, when we add k, let's say we reach n. So we need to find the number of step, right? We need to find the value of k. So I just put this k into k plus 1 by 2, because it is nothing but addition of k natural numbers. So which is nothing but k into k plus 1, right? K plus 1 by 2. And I would be picking the highest term, basically highest degree term, which is k square. So k square would be equivalent to n. K is nothing but root n. K would become root n. So see, guys, you don't have to be specific here. Like, we are not equalizing them. We are just concerned about the order basically. So k would be root n here, guys. Okay, k is root n, because we needed the value of k. K is nothing but the number of steps, number of times the loop has executed. That is our time complexity. Okay, so I hope it's clear now. Yeah, Katie, we can actually, I think we can have the next quiz question.
Yes, sir. I'll be sharing my screen right now, and also I have updated the attendance link in the description and also pinned it in the chat. Guys, you can get the attendance link from description and also in the chat. All right, thank you. So I'll be sharing the screen right now so that they can get up with the quiz for.
Yeah, guys. So as she mentioned, attendance link has been shared in the chat box. Also, the quiz question link is being shared with you. I think it's now visible to you all. Just fill your attendance, go to this quiz, and let me know when you are done. Okay.
Guys, you can also go to quiz 1 after completing the quiz 4. The link for quiz 1 will also be added in the chat. Like the mods will be sending the quiz 1 links also. After you complete with the quiz 4, you can go for quiz 1 also.
Yeah, guys, please let me know when you are done actually. Okay. Both the things like your attendance and also this quiz. The two quizzes you have to do, right? So quiz 4 and also quiz 1. So you can attend both the things. Please let me know when you are done. So guys, I hope everyone is done with the like this attendance and this two both the quizzes. So I think we can like move on to our next set of discussion. Like I have one more example to discuss, and we'll discuss that. And I have yes one assignment question also. I think we have one more quiz question also. So let me quickly like discuss one example with you, and then we can go to the quiz. And also I would give an assignment. So for I equal to 1, I less than equal to n, I plus plus, and this one is for j equal to 1, j less than equal to n, j equal to j into 2, and let's say printf high. Yeah, just this question. So let's discuss like what would be time complexity. As I said, you would be fascinated to do this question. Like, oh yeah, it's very easy question. So for the outer loop is running for n times, inner loop is running as it is very clear that okay, it would be log n and I would say n log n. But yes, I would like would like to like you to see in this perspective. Like I 1. So I would like first iteration I would be 1. How many times j would run? So obviously it is clear, right? It would run for log n times. Similarly, when I would be 2, j would again run for log n times. Then similarly, when I is 3, j would run for log n times. So same thing goes on when I value would be n, it would run for log n times. So you just need to add these things up. That would be our total number of times this high, this printf high statement is getting executed. So this is log n plus log n, so on up to log n. So how many log n, guys? N times. So what is the time complexity then? It is big of n log n. Okay, so time complexity is nothing but n log n for this code snippet. Okay, so this is n log n, guys. So I hope you are following whatever we are discussing. So yeah, I know it would be very quick, but we can we have now, Katie, the last quiz question for them? Can we have now that?
Yes, the quiz one. I'll be sharing the screen. All right. Because the quiz 4 was the last one which I shared. So the
Okay, okay.
last quiz is the quiz 1 now.
Yeah, yeah, yeah,
That's
yeah. Sure, sure. I think yeah, more maybe some of them, a few of them might not have like gone into this quiz one, so we can reshare that quiz one thing again. That would be very
yes.
nice of us.
All right. All right. So
Yeah, sure. So yes, guys. So quiz one link is again being shared because we thought some of you could have missed it out because it was three things. So there is a chance some of you would have missed it out. So Please go to this quiz one link if you have not done. Okay, so you can go to there and you can submit your answers. Yeah, doubt you can ask. Put down your chat. They put down your question in the chat box. Sorry. Yeah, guys. Yeah, you can put your question. Katie, Katie, can you be on mute for a moment? Best case time complexity notation is big omega, Neeraj. Big omega, that big omega I had shown, right? Kind of ohm kind of symbol that is used for best case, and average case is that theta. Okay. Yeah, we would talk about that lighting stars. Yes, we would talk about sorting algorithms that is kept for some upcoming session. Yes, we will do that. Okay, so I hope all those who had left out or might have left out with this quiz one thing might have now done that. So it's time I give you that assignment question actually. Okay, so I'll quickly share. Yeah, I've already shared the screen. So let's clear this thing and I would give the question. It's an interesting question, guys. I hope everyone would like, and I hope every one of you would answer it correctly. So this is an assignment question. Actually, take it as an assignment. Anyway, would also share a link to this question after the session. Equal to n I plus plus, and yeah, okay. Let me change this question a bit. So let's say this is I into 2, and then we have for j equal to 1, j less than equal to I, j plus plus. Okay, and then we have this printf high. So you need to find out the time complexity for this one. I equal to 1, I less than equal to n, I equal to I into 2, and then we have this j inner loop as j equal to 1, j less than equal to I. Okay, this is not n, guys. So this is j less than equal to I, and then j plus plus printf high. Okay, so this is your assignment. Take this as an assignment. So yeah, so I would quickly brief you out like what exactly we are going to have in the next session. I'll also give you a brief intro about that. So in the next session we would be discussing about more about loops basically. Okay, some concept about loops, and yes, we are also going to look forward for this pattern kind of question. So when I say this pattern kind of question, if I say you this pattern, if I say you this pattern, so what would be the logic for printing this pattern? So when you say see this, I think most of you might have understood by the time you would be using this nested loop for this. Okay, yeah, I'm not talking about Python people. Python in Python, the we can also do in a different way. Yes, and it would be shared. The attendance link, sorry, this assignment link and all, it would be shared in the community. Don't worry about that, guys. So just be here right now. Just be concentrate here. Whatever we are discussing now, everything you would be informed. Don't worry about that. Yeah. So, but this thing we need to have a nested loop basically. Okay. So yeah. So how many rows are there? 4 rows are there. So kind of this you can remember, or yeah, you can keep something in mind. So this outer loop will decide how many rows are there. Okay, normally we go in that way, guys. Outer loop will represent the number of rows, or you if you the number of times outer loop is going to run will decide the number of rows, okay, in your pattern. So okay, there are 4 rows, so I will start from I equal to 1, I less than equal to 4, I plus plus, and then I need to have this inner loop. How many columns? Inner loop will decide how many columns here. But if you see here, the number of column is different. Okay, so in first row there is only one column. In second row, there are two columns. In third row there are three columns, and in fourth row there are four columns. So as the row number changes, the column is also getting changed, right? In first column, one row. In second column, second row. In third column, third row. Sorry, three. So in third row, three columns. In fourth row, four columns. So it is basically the inner loop is running how many times? Outer loop times. Let's say I value is 1, so inner loop is running one time, only one star. When I value is 2, inner loop is running two times, 2 star. When I value is 3, inner loop is running 3 times. So basically it is running I times, you can say. So you can start j equal to 1 and you can put j less than equal to I, j plus plus. So what we need to put here, we need to print star, because we have to print a star, right? Okay, and then what we need to do, guys, so this is the inner for loop. So after completion of this inner for loop, we have to excuse me, we have to get to the next line, guys. Okay, we have to go to the next line. So if you see here, after completion of inner loop, when I say inner loop is completed, that means all the column of one row has been completed. And when you have printed all the column of one row, then you have to go to the next line, right? So here I'll put this printf slash n. Again, I'm saying, guys, I'm just writing in a short form of printf as pf. Don't write pf in your actual code. So this particular thing would print this pattern. But yes, one more thing is, in the next session, I would give you one more way. Basically, I would give you a different perspective actually to this question. Okay, for this exact pattern, for the same pattern, I'll give you a different perspective. Yeah, maybe the code would be different. Sorry, the code may be same, or maybe there would be minor modification to it. But we'll get the same pattern, but we'll have a different perspective. Okay, why I would be giving you a different perspective, because that would help you to solve or to write code for other patterns, guys. Okay, so yeah, guys, so I hope you understood even this one and all other stuffs what we discussed up to this moment. I hope you enjoyed this session. So we'll be coming up with more topics and more things in upcoming session. Okay, so yeah, guys, so I hope we are done with this session. If you have any doubt, you can ask me now, or else we can just close up this session and we'll be meeting in the next class. Any doubt? You can ask, guys, in the chat box. Chat box is all yours now. Yeah, it was always yours. So yeah, assignment link would be shared. No issue on that. It will be shared. You have to like get to this community thing. Okay, it would be shared. Everything would be there in community actually, so you can find it there. Okay, yeah, thanks for the response. Today's class was about time complexity and basically an intro to this looping structure, this pattern thing. So we would also discuss, we'll continue the discussion of pattern thing in the next session also. Okay, right? So okay then, guys. So I hope it's like fine. We are done with this session, and I hope yeah, I see no doubt from you. Okay then, so take care then, guys. Bye, and we'll meet in the next session. And thank you, Katie, for your help throughout the session.
Thank you, sir, and your help too. So we shall end the session.
Yeah, sure. We can end it. I see there's
All
no
right.
doubt from them, so we can end it.
All right. All right. Thank you so much, sir.
Thank you.